So, we are going to perform an experiment on DHCP and the subnetting. The concept of subnetting is dividing a network into logically subnetworks so that the IP address assigned allocated to it is efficiently used and not wasted. And another concept is of DHCP, that is the dynamic host control protocol. The requirement of DHCP is that we allocate it is used for allocating of IP addresses to individual PC to the individual systems. Now, assigning static IPs to each and every machine in an industry is not feasible. So we use a DHCP server to dynamically allocate whenever PC connects into a network, and it can access the network from and transmit the data from one network to another network. So in our case, we have been allocated with an IP address that is 198.20.20.0 with a subnet of 24. Over here, the concept of subnet arises as it is mentioned that the subnet is 24. That it means that we need to, as the IP address ranges format is from consists of 8 bytes in a block of 4. Initially 2 bytes are of network and the remaining are from the host. So if when we want to take 24 host from the 24 bits from the IP address, so initially we can get 16 directly from the network host. Now what if we want to expand the network? So for that we are just taking another 8 bits from the host part, that is from the right hand side, into the network. So after removing that, the from the 32 bits we are removing the 8 bits, we are getting the amount of 24. So when we are configuring for 2 raised to 8, that the remaining host bits are 8 bits. So now 2 raised to 8, that is 256 bits. 256 users can get allocated the IP address in this network. Now we'll show you how the network IP address division and subnetting is done in over here. When we are considering the network, our network is considering of 4 networks. That is the network 1 from router 1 to router 1, router 0 to router 1, router 0 to router 2, that is the second network, and the third network is the from router 1 to the switch and router 2 to the switch. So in this way we have consisting of 4 networks, and we need to divide it into efficiently. We need to divide the IP address so that the IP addresses are allocated in a proper manner. So in a range that from a network from router to router, we need 4 IP addresses, that is 2 IP addresses for this end, 2 IP addresses for this end, from which one IP address, that is the initial IP address, is reserved for the network, and the last IP address is reserved for the broadcast. So when we are considering this IP address 198.20.20.0, that is the IP address for the whole network. Now we need to divide it into 4, that this 198.20.20.1 and 198.20.20.4, that is both 1 and 4 are reserved, so we can only use 2 and 3 in it. So from 1, 2 and 3, these are the IP address that we can use. So over here we have used the IP address 1 for the router end of left side and the 2 for the router end of this side. Similarly, this has to be applied on the right side, that this 0 to 4 has been occupied. Now we have remaining with the 5 to 8. So the 5 is reserved and the 8 is also reserved for broadcast and network. So we can use the 5 and the 6. The IP address for the right hand side will be the 5, and for the router 2 it will be the 6. Now after that we need have the network on the left hand side of the router over here. So we are consisting of 3 4 5 6 6 end PC systems and 3 equipment devices such as server, switch and the router. Now when we are allocating the IP addresses, we need 3 static IPs for these components, thus we cannot dynamically allocate the IP address to these components. So in all we need 6 uh, 6 7 8 9, and that is the 9 IP addresses for this network, in which these three are static, and the remaining end devices will be dynamically assigned the IP using the DHCP server. For dynamically allocating the server the IP addresses to the system, we need to configure the DHCP as over here. In the server you need to go in the services. In the services you need to go in the DHCP. Okay, over here now, as I had mentioned, we had assigned three IP addresses to the devices, that is 20.20.17 to the router, 20.20.18 to the switch, and 20.22.9.19 to the server. So over here, after division of the subnets, we have the starting address, that is the 198.20.20.16, which means from these addresses the DHCP server can allocate the IP addresses to the systems in any number. The maximum number of IP address that an server can allocate is the 11. After the 16, 17 and so on till on the 11 devices, maximum can connect to the DHCP server, and the DHCP server can allocate the IP address to the systems. Similar configuration for the DHCP is being performed on the right hand side of the network. Over here, as you can see, there are more PCs than this, and the server over here can has been set it as 32. That is, server can allocate the IP address to the end systems from the 32 till the devices such as 27, as we have divided the subnets. Okay, now it's time to check whether the DHCP server is allocating the IP address to the systems or not. For that, we need to just click on the PC4. In previous part, we were configuring the IP configuration as a static, and we were manually entering the IP addresses. In this case, we don't need to do that. We just need to click on the DHCP server over here. It will just request an IP address, and it will successfully allocate the IP address. That is, this server has allocated an IP address to the system, and this is the following IP address for this system. Similarly, we can just ping and check for this PC also in the network too. We'll just click on the PC2, and in the desktop we'll go in the IP configuration, and we'll just change this mode from static to DHCP. Over here, the DHCP will dynamically allocate the IP address to the system 2 over here. Now we need to check whether the packet is being transmitted from the network 1 to the another network. So we'll just mark this IP address, that is 198.20.20.39, and we'll just ping it from the PC1. We need to click on the PC and the command prompt, and we need to just ping the command 198.20.20.39. As you can see, there has been a bit loading in it. The reason for this loading is that there was a request timeout initially, because the system, that the switches and the router that in the network has kept a few ICMP packets in itself for ARP routing, that is caching the data, the addresses from the host to itself. So that's why a request timeout was seen and the remaining bytes were sent. Now when we just reload it, it will be 100% successful, because the switches has already kept the ICMP packet in it over here, as you can see the command. So here we are completed the simulation. Thank you.